The high tunnel irrigation system that I have installed is still very much a part of the natural hydrologic cycle. In my system, I have three input sources for the water. One is I use a swimming pool as a large cistern that collects rainwater off a shed roof. This water is then transferred through piping into the main trunk system. I also have a farm pond that is used to collect rainwater and surface runoff. And then thirdly, I have a city water system that pulls water out of a local river and cleans it and sends it out as potable water. So the natural rainfall impacts all three systems and increases the supply of those watering sources. Then, if you notice the elevation change at my farm, water is piped underground down to the high tunnel through a system of pipes. You'll have a picture of a valve box that's showing the different valves that I have to go and move the water. In this valve box I can move the water whether it's from the city water system or the pond or through the cistern. I can move that water through the pipes into the high tunnel. As water drops in elevation, it increases in pressure about a half a psi, half a pound per square inch per foot of drop. The valves in the valve box or the well near the high tunnel release the water from either of these three systems to the filters. The filters clean out any sediment and algae out of the water, move the water then to the pressure regulator, and the pressure regulator is used to keep the water at a constant 8 to 10 pounds of psi to go into the system. Then the system goes and moves the water through a series of small pipes, tubes, that strategically discharge the water into the emitters and drip tape that you see in the pictures. This allows for the efficient water distribution and water conservation.
And solar energy drives the hydrological cycle. So as heat in the high tunnel increases, water in the soil evaporates, and evapotranspiration occurs in the plants, and water re-enters the atmosphere. Once in the atmosphere, the warmer air moves upward and cools all the way until it reaches the dew point, which is 100% relative humidity. This is where condensation occurs and clouds form. Cooler air holds less water than warmer air, and eventually the air becomes saturated and precipitation is generated. This precipitation puts water back into portions of the hydrological system